Our learning goals for this lecture, we're going to explain the More Things Change lab. What we should be able to do after we're finished is, number one, describe the states of matter. Number two is describe the similarities and differences of elements, compounds, homogeneous mixtures, and heterogeneous mixtures. Describe an object by its chemical and physical properties, and distinguish between chemical and physical changes. Now, in the More Things Change investigation, we were asked to look at calcium chloride, phenol red, and baking soda. The one thing we have to do is we have to describe these things, and we can look at them, and just by their appearance and how they look, we can look at calcium chloride and realize that it's fine, white granule solid. We could describe it like that. The phenol red, we could say it's red liquid, and it has a viscosity similar to water. In baking soda, we could say it's fine, white, powdery solid. And basically, we could describe these things as we saw them. Another way to describe them, which we did, was by the state of matter. We said that matter can be defined by its state. It can either be a solid, liquid, gas, plasma, fermionic condensate, or a Bose-Einstein condensate. Remember, we mainly stick with solid, liquid, gas, and plasma. That's really in the scope of this. But even in defining it in those four basic states of matter, that doesn't tell the entire story. The question that we have to ask ourselves is it pure? Now, pure substance, those are things that are composed of a single element or compound. It's really important to note element or compound. It could be either one of those, but it is only composed of a single element or a single compound. Pure substances have a single homogeneous composition. Every sample has the same characteristics, and every sample has the same composition. So if it's a single element, it is a pure substance would be only that one atom. And it's just a whole bunch of that one atom. Okay? Or if it's a compound, it's just that one compound. It's just that one, a whole bunch of that same thing. Now, if it's pure, we have to ask ourselves how many types of atoms are there. An element is a single type of atom. Okay, this would be an example. We could say that this over here, this element is an oxygen. And that's just one single oxygen atom. And we could say that this compounds have multiple, sometimes different, atoms arranged the same way. So if we're looking at this and we're calling this water, this pure water would be made up of only two hydrogens and an oxygen bonded together. And it would just be that water molecule. It wouldn't be anything else. Now, if it's not pure, so if it's not a single element or a single compound, if it's not pure, then we can break it up into mixtures. There's two types of mixtures that we have. We have our homogeneous mixtures, which that is a uniform combinations of two or more substances. An example of that would be milk. If we look at it, you shouldn't see anything floating in your milk. It's just one smooth composition throughout, but milk is made of a bunch of different things put together. Okay, a combination of two or more substances. A heterogeneous mixture is a non-uniform combination of two or more substances, such as orange juice. The main difference between these two, a heterogeneous mixture, the one thing that I would note, you can see things floating in it. Okay, in milk, you should never see anything floating in it. If you do, it's not good milk. Okay, but if you take, for example, this picture over here, if you look at the orange juice, you can see there's something floating in the orange juice. So therefore, it's a heterogeneous mixture. Okay, if you can see it, it's heterogeneous mixture. If it's can't see it, it's a homogeneous mixture. Now, the flow chart that we kind of use is we have to ask ourselves these questions to figure out really what it is. The first question that we ask ourselves is, can the matter be separated into different things? If the answer is yes, okay, so we ask ourselves this question, can it be separated into different things? Then it's going to be a mixture. Okay, and then once we figure out the mixture, all we have to do is ask ourselves, is the mixture the same throughout? Okay, meaning, can we see distinguishable parts? If we can't, okay, the mixture is the same throughout, so yes, it is the same throughout. That's a homogeneous mixture. But if you can see things floating in it, it's not the same throughout, it would be a heterogeneous mixture. Now, if we say no to the first question, can the material be separated into things? No. Okay? That means that we're going to have a pure substance. And then we ask ourselves, is there more than one type of atom present? If yes, we know it's a compound. If no, then it would be an element. Now, if we have a mixture, we can separate it. That was one of the questions that we asked. Can it be separated? And if it's a mixture, it can be separated. Types of separation that we use. The first one that we can look at is filtration. We see this all the time. Any type of water filter uses that physical separation technique of filtration. It's just filtering out the solid particles and the liquid that part runs through the filter. Distillation. Okay, if we were to take seawater, it has salt and it has water in it, and we just wanted to get the salt out. Well, what we could do is we could boil the water, all the water would go away, and we would be left with the solid. That's called distillation. Another type of separation technique is decanting. That's where we let all the solids settle to the bottom and we pour off the liquid. Or we could use a centrifuge machine where it spins a sample very quickly so that the components with different densities separate. We see that the centrifuge used a lot if you watch shows like CSI or something like that. Another physical separation technique would be paper chromatography. Okay, it's used to separate mixtures because the different parts of the mixture bind to the paper and move slowly than others. You can see this if you practice it with ink. If you put a line of ink at the very bottom, like we've done here, and then you dip it in some water, the liquid will move through it and the particles will separate out. All right, example A1. It says human blood is a heterogeneous mixture, and plasmapheresis is the process by which blood is removed from the body, separating into its cells and plasma. The plasma is then returned to the body, and what we want to do is determine the most effective method for separating the blood cells from the plasma. Okay, so we know that it's a mixture, so the first thing that we should understand is we're going to separate it through a physical separation technique. And since it's a heterogeneous mixture, one thing we can do, and the most common thing done with plasmapheresis, is that they actually spin it through the blood through a centrifuge. And basically they spin it out, and because the particles are at different densities, they can separate it out and then return it back to the body. All right, example A2, it says classify the following substance as an element, compound, a homogeneous mixture, or a heterogeneous mixture. When we're looking at this, the one thing that we need to look at is that the substance that we're looking at is brass, and brass is made of a bunch of different metals put together. So use that information and see if you can't answer that question. Example A3, it says classify the following substance as an element, compound, homogeneous mixture, or heterogeneous mixture. When you're looking at this, the answer that you should get is that it's a heterogeneous mixture. Make sure you can tell me why. Now, in looking at the lab, did any of the following things change the composition of the fluid in the bag? Did compressing the fluid change what we had? Did heating the fluid or shaking the fluid or reducing the volume of the bag change the composition of the fluid in the bag? And what we should see is it doesn't change what it actually was. And what we call those things, those are physical properties. A physical property, it's a description of an object that is not related, and the key word here is not related to its ability to change to another substance. Okay? When we're looking at physical, the one thing that I would put is that physical properties or physical changes do not change what it is. Physical, nothing happens to the substance's composition. Is density a physical property? Well, yes, it is, because when we're measuring the density, we don't actually change what it is. Okay, a list of some physical properties. We have mass, color, temperature, absorption, malleability, area, pressure, specific heat, viscosity, density, boiling point, freezing point, brittleness, magnetism, volume, solubility, thermal conductivity, and ductility. Those are a list of physical properties. When we look at the investigation again, did any of the following have changed the composition of the fluid in the bag? Mixing the calcium chloride with baking soda. Okay, when we look at that, mixing the calcium chloride with baking soda, nothing happened. Then we still had calcium and we still had, or calcium chloride and we still had baking soda, but nothing actually happened. Once we mix the phenol red into it, we see that something happened. We had a change, and we had those would be our chemical properties. And what we see is chemical properties are a description of what will happen when or how an object can change into something else. When it changes into something else. And those are going to be our chemical properties. And what we measured, what we looked at and observed qualitatively in the lab, we measured, or we looked and saw our chemical properties, and we saw everything reacting with each other. The question, is electrical conductivity a chemical property? Well, in some cases it is a chemical property. In some cases it is a physical property. It just depends on how we are using it. And the main thing here is anytime we're looking at chemical, there has to be a change in the composition. It has to change into something else. Physical properties don't change. Chemical properties do change. So when we observe physical, nothing happens to the composition. When we observe a chemical property, we are changing it into something else. List of chemical properties, we see combustibility, emitting light, reactivity, ability to change color, corrosiveness, ability to decompose, explosiveness, and ability to give off heat. Those are just a list of chemical properties. Now, example B1. Archaeologists uncover what they believe to be an original copy of the Magna Carta from 1215. What type of properties should be examined given the unique artifact? When we're examining this, we don't want to change what we actually have. We don't want to change and break off pieces from it because it's a very important document. So anything that we are going to observe or examine should be a physical property of it. We shouldn't break off pieces and look at the chemical properties, because once we look at the chemical properties, it changes what it is. So we should only be looking at the physical. Example B2. It says scientists discovered that a potassium-doped Buckminster-Fuller molecule becomes superconducting at 18 degrees Kelvin. Describe the chemical and physical properties in this narrative. Whenever we're describing this and we're looking at it, some things to pay attention to. It's superconducting. It gives us a temperature, 18 degrees Celsius. Those are some things that we need to focus on when you write your answer. Example B3, it says describe the physical and chemical properties of the sun. We should describe how it emits light. We should describe heat. We should describe the size of it. Those are some of the things that can be in our answer. Make sure you go back and put what's the physical, what's the chemical. And remember, physical doesn't change what it is. Chemical, it actually changes into a new substance. Now, when looking at the lab, mixing the powders together did absolutely nothing. But what happened when the phenol red was added? When we added the liquid, we had a bunch of different changes that occurred. We actually saw things happen. To figure out what type of change we saw, let's first look at what a physical change is. A physical change is something that changes the form of the substance, but not the identity of the substance. If we have a cup of water, and here's our water, and we're going to say that that water is going to be a liquid. Okay, so this one's a liquid. And then we place it in the freezer. It freezes into solid water, but it's still water. It didn't change. It's still water, just a different state of matter. Main thing we need to understand is that to observe, or when we're looking at a physical change, we're also looking at the physical property of it as well. So if we're looking at the physical properties of it, we can also look at physical changes of it. But this is actually has to have a change in the state of matter. The things that we look for, evidence for a physical change, it can be the change in shape, change in state, meaning going from a liquid to a solid, change in temperature. When we're looking at this, this is a tricky one. You got to make sure that the change didn't occur because of something chemically happening to it. It could be we set ice out and it melts, it changes the temperature, and it changes the state of matter as well. Or we could have the change in texture. We could have something that's very coarse, and then we grind it, and it becomes into a powder. Now, the other change that we can have is a chemical change. That's the process by which a substance is changed into a new substance. Anytime we're looking at a chemical property, or we want to observe a chemical property, we have to have a chemical change. It has to change into something different. If we take a cup of water and put electrical current through it, and we see that it'll conduct that electricity, but what happens is it's splitting the water into the hydrogen and oxygen. It splits it into the gas. And what we see is that when it splits into the gas, it's breaking it up. It's something different than what it was, so that would be a chemical change. Some evidence for a chemical change is producing gas bubbles. The main thing here is producing. If we take a bottle of Coke and we open it up and the gas, the carbon dioxide comes out of it, that's not actually a chemical change, that's a physical change, because the Coke is not actually producing the carbon dioxide. We could have a change in temperature, and this could be evidence of a chemical change if it's happening along with a chemical reaction. We could have an endothermic or exothermic reaction, and that would change the temperature. The substances disappear. A precipitate forms. That's when we put two liquids together and a solid kind of clumpy stuff forms on the bottom. We have a color change, or an odor produced, or apparent change in the mass. Main thing with both physical and chemical, it's not just seeing one of these, but it's seeing a combination of these, and you have to look at actually what is happening. Okay, example C1. It says the identification of a compound often requires manipulating the sample in numerous ways. Which type of change could be employed in the process of identifying an unknown, and justify your answer using the clear method? Remember, the clear method is going to be our conclusion, evidence, and reasoning. So our conclusion here should be that we were going to use physical changes because we don't want to change the identity of the substance. So that's kind of our conclusion and our evidence. And the reasoning is that a chemical change would change the identity of the unknown. It would change it into something else, and so it wouldn't allow us to study it afterwards, and it changes it into something else. Example C2. You mix yellow Kool-Aid and red Kool-Aid and notice a distinct color change. Determine whether a physical or chemical change occurred. Justify your answer using the clear method. Remember, it's conclusion, evidence, and reasoning. Make sure you pay attention to, just because there's a color change, does that mean that it's chemical? Does it mean that it's physical? Make sure you're looking at it. Make sure you're looking at, remember, chemical, it changes the composition of it. Physical, it doesn't. Example C3. Name one example of a physical change and a chemical change done in the kitchen when preparing a meal. One example of a physical change would be boiling water to cook pasta. One example of a chemical change would be baking a cake. Think of any others that you can think of and write those down.